Hello, my dear boys. Good morning, everyone. Welcome, all of you, to my online physics class. We are discussing on some board question, especially Dhaka board question. Okay, so let's see another creative question from Dhaka board 2020. So, today our creative question is: in summer, a beverage seller wants to make a beverage of temperature 15 degrees Celsius. For this reason, he mixed 20 kg of water of temperature 35 degrees Celsius with 0 degrees Celsius temperatures some ice. Okay, I'm repeat the stem again. In summer, a beverage seller want to make a beverage of temperature 15 degree Celsius. For this reason, he mixed 20 kg of water of temperature 35 degrees Celsius with 0 degree temperatures some ice. Here the latent heat of melting is 336,000 joule per kg and specific heat of water is 4200 joule per kg per Kelvin. Okay, so here our questions are: question number A, what is the coefficient of linear expansion? Okay, now question number B, where the water is rapidly evaporated when the same amount of water is placed inside a glass and a bucket. Explain briefly. Okay, where the water is rapidly evaporated when the same amount of water is placed inside a glass and a bucket. Okay, question number C, determine the ratio of velocity of water and beverage. Okay, so here we need to determine the ratio of velocity of water and in beverage. Okay, question number D, whether the ice is fully melting or not. When the man mixed 6 kg ice for making beverage where the mixture temperature is fixed. According to our stem, we say that here our mixer temperature is 15 degrees Celsius. So here we need to fix the mixer temperature 15 degree Celsius. Okay, so analyze mathematically. So this is our today's creative question. Okay, this is one of the questions of Dhaka board question, and this question sets from is set from chapter 6. The name of this chapter is effect of heat on matter. Okay, so let's calculate these questions or this problem step by step. So our first question is, what is the coefficient of linear expansion? Okay, and the answer is, the coefficient of linear expansion is the change in length of a specimen 1 unit long when its temperature is changed by 1 degree. Okay, I'm repeat it again. The coefficient of linear expansion is the change in unit or a change in length of a specimen 1 unit long when its temperature is changed by 1 degree. Our question number B is where the water is rapidly evaporated when the same amount of water is placed inside a glass and a bucket. Okay, the answer is if some amount of water is placed inside a glass and inside a bucket, water will rapidly evaporate from the bucket. Okay, so answer is water will rapidly evaporate from bucket because the reason that the surface area available for evaporation. The glass has a very small opening surface of water opening surface comparing to that of bucket. So from the bucket's upper surface of water, the water will evaporate. As the surface area is more, evaporating water absorbs weight from its neighboring surface as the surface of contact in case of bucket is more. So it can easily set the required heat and evaporate. So we can say that water will rapidly evaporate from the bucket. Okay, so our question number C is determine the ratio of the velocity of water and beverage. Okay, so let velocity of sound in water is VW and velocity of sound in beverage is VB. Okay. Now, here given that the temperature of water is 35 degrees Celsius and converting Kelvin we get 308 Kelvin and the temperature of beverage TB equal to 15 degrees Celsius and converting Kelvin we get 288 Kelvin. Okay, so we know that the velocity of sound is directly proportional to the square root of the temperature. Okay, we know that the velocity of sound is proportional to the square root of the temperature. Okay, so here we know VW by VV equal to, or we can write, we know V is proportional to root of T. So according to this formula we can write VW by VV equal to root of TW by TB, and putting the value we get root of 308 and 288, and the result is 1.034. okay, VW by VB. okay, then the ratio of velocity of sound in water and beverage is 1.034. okay, the ratio of velocity in water and beverage beverage is 1.034. So this is our answer for question number C. So now we will calculate the question number D. Okay. Here given that according to the STM, given that mass of water MW equal to 20 kg, and here temperature of water theta W equal to 35 degrees Celsius or 308 Kelvin. Okay. Here mass of ice used according to the question we get it, the mass of ice used is 6 kg. Okay, and temperature of ice, we know that the temperature of ice is 0 degree Celsius or 273 Kelvin. Now here given that the latent heat of melting ice LF, which is denoted by LF, is equal to 336,000 joule per Kelvin, joule per kg, joule per kg, and specific heat of water SW equal to 4200 joule per kg per Kelvin, and mixture temperature is 15 degree Celsius or 288 Kelvin. Okay. Now let the amount of ice required be M. Here our condition is the mixture temperature will be fixed, and that is 15 degrees Celsius. Okay, and for this mixture temperature, our question is that the amount of ice 6 kg will be melt or not. Okay, so here we can assume that at mkg borough will melt to keep temperature fixed, to keep mixture temperature fixed in 15 degree Celsius. Okay, so here we know that according to the theory of calorimetry, we know that heat gain equal to heat loss. Okay, here the ice of 0 degree Celsius or 273 Kelvin will gain heat, and the water of 35 degrees Celsius temperature will lose heat. Okay, and the ice will gain heat in two parts. Here firstly it will convert 0 degree Celsius ice to 0 degree Celsius water. Okay, in this part it will get latent heat, and after that 0 degree water will convert to the mixed temperature water. Okay, so by this two part ice will gain heat, and here 35 degrees Celsius temperature water will lose heat, because the 35 degree water will decrease to 15 degree water, because it is the mixture temperature. Okay, now in first step 0 degree ice will convert to 0 degree water. So in this case it will in this step the gain heat will be M here, this M L F plus, and here this amount of ice or this amount of 0 degree Celsius temperature water will convert to 15 degree Celsius water. Okay, so we can write M is W del theta, okay, equal to here m water of 35 degree is water and del theta again, or we can write mLF plus here LF is 336000 plus M is M into 4200 into here 288 minus 273, okay, equal to here M water is 20 kg into 4200 into here temperature is decreased from 35 to 15, okay, so we can write 308 minus 288, okay, or calculating this we get 336000 M plus 288 minus 273 into 4200, okay, or 63000 M equal to 308 minus 288 into 4200 into 20, 1680000. Therefore here M will be bhag 336000 plus 63000, okay, and the M will be 4.21 kg, okay. So we see that here the man used 6 kg, but here condition is the temperature of mixture will need to keep fixed at 15 degrees Celsius, okay. Now here we assume that the amount of ice is M to keep fixed this temperature 15 degree Celsius, okay. So here our after calculation we get the value of M is 4.21 kg, okay. So we can say that 4.21 kg ice will melt, or ice will 4.21 kg ice will fully melt to keep the mixture temperature fixed in 15 degree Celsius, okay. But here the man used 6 kg, but here the man of beverage man of beverage seller used 6 kg ice. So according to this analysis we can say that 6 kg ice will not fully melt when making beverage where the mixture temperature is fixed, and that is 15 degree Celsius, okay. So boys, this is all for today. In our next class we will try to discuss another board question, okay. So until then, thank you boys.